Yeah, hi, good morning everyone. So shall we begin the session? Today's topic is continue with the chapter number 8. In the last class we have started with the chapter number 8, that is overview of the system analysis. So that is the system control and the system monitoring, how we are going to do the system monitoring. That we have started with the chapter number 8 in the last class. Okay, so wait for others for another 5 minutes. We already discussed about the design objectives, reliable system, error avoidance, error detection and the correction, error tolerance, and what are the various causes of error. Now, the today's topic is the maintenance of the system, how we are going to maintain the system, that is the system maintenance. So, any doubts, anyone in these introduction, design objectives, reliable system, error avoidance, error detection? Yeah, that is the difference between the error detection and the error correction. First of all, you have to detect the error, then we have to correct the error. Then error tolerance means whether we are going to tolerate the errors or not. So we have discussed about the no program or the system design is perfect at any time, and the communication between the user and the designer is not always complete and clear, and time is usually the short. That's why there is a result that is, or that's why the error will occur, or the result is the error. And the number and the nature of the errors in a new design depends on the multiple factors, several factors. First one is communicate between the user and the designer. So there's a communication that will take out between the user and the designer. Then the programmer's ability to generate a code that reflects exactly the system specification. What are the system specification that is going to reflect, that is going to do, that is to able to generate a code that reflects exactly the system specifications. And these factors put in an increasing burden on the system analyst to ensure that the success of the system will develop, and that should be any efforts that will be put up by the system analyst to make the quality of the system increase. And most of the issues, we can say the errors, covered under the design, development, or testing and the implementation phases. And when we say that the system is reliable when you rely on the system. That means it does not produce dangerous or the costly failure when it is used in a reasonable manner. So then only we say that the system is reliable. It does not produce a dangerous or the costly failure when it is used in a reasonable manner. That is in a manner that the typical user expects it's normal. This definition also recognizes that the systems may not always be used in the way that the designer expects. And there are also the steps analysts that can take to, or there are the steps that can be taken by the analyst to ensure that the system is reliable when it is installed, and the reliability can be maintained after the implementation. The next one is approaches to the reliability. So there are two levels of reliability. The first one is the system is meeting the right requirements, and how it will be going to make the requirements as a very fruitful and the effective. There's also second level of system reliability that involves the actual working of the system delivered to the user, and at this level system reliability is used with the software engineering and the development. So what is an error? So anyone can define what is an error or the bug. Yes, very correct definition. When the system does not produce the expected output, that is an error. Whatever we expect from the system that is not produced by the system, that is known as the error. But again, there is a contrary condition that the no program is free from the bugs or the errors. Then how to avoid the error? There are multiple methods by which we can avoid the error. That is, first of all, focus on the investigation stage, focus on the requirement gathering stage. Then focus on the design phase. That means what are the four areas in which the improvement will be taken out? One is the requirement phase, then design phase, development phase, and the testing phase. And then what are the various causes of error? That may be manufacturer error, that may be system analyst error, that may be not obtaining the right requirements. So how we are going to maintain the system? What are the various maintenance issues? That is a today's topic. So when systems are installed, they generally are used for the long period. The average life of a system is 4 to 6 years. So general life of a system is 4 to 6 years. After the 4 to 6 years, the system will get outdated, or we can say wear off. So we have to change the parts of a system. So we have to change the parts of a system so that it will be used by another user, or it can be used by n number of users very efficiently and effectively. So average life is 4 to 6, but the most oldest is over the 10 years. If the system is over the 10 years, that means that is a perfect system. All the requirements are met with the specified objectives. Everything is okay from the system analyst and from the developer and everything. But this period differs from the system to system to maintain the system. So because of the use a system receives after it is fully implemented, analysts must take the precautions to ensure that the need for the maintenance is controlled through the design and testing. So there's a need of the maintenance that is required for the design and the testing, and the ability to perform it is provided through proper design practices. That is, what are the various design practices method that is used to maintain the system maintenance. So first one is maintenance issues. What are the various maintenance issues that will be carried out in the maintenance of the system maintenance? So it is saying that the many private university and the government studies have been conducted to learn about the maintenance requirements for the information system. And the studies have generally concluded the following, that from the 60 to 90% of the overall cost of software during the lifetime of a system is spent on the maintenance. That is 60 to 90% of the cost of software during the lifetime of the system. That is, during the lifetime of system, nearly about 60 to 90% will be the cost of the maintenance. Then often maintenance is not done very efficiently. In documented cases, the cost of maintenance, when measured on the basis of writing or cost of the writing, each instruction in the code form is more than 50 times the cost of developing a system in the first place. That means whenever we are using the documented cases, the cost of the maintenance is more than the 50 times the cost of developing the system in the first place. Then software demand is growing at a faster rate than supply. So there's the demand of the more and more system than the supply, and many programmers are spending more time on the system maintenance than on the development. Because again, that line is saying that no system is perfect. So there's a requirement of the maintenance, maintenance, maintenance. And studies have been conducted that in some sites, two-thirds of the programmers are spending their time on the maintenance of the software. So two-thirds of the programmers can, or yeah, two-thirds of the programmers are spending their time on the maintenance of the software. And there is a backlog of the new development work. Moreover, there is a hidden backlog also that requests for the development work that the user do not bother even to submit because they know it will be years before development can begin or be. And there's the information system and the organization that also serves as in a constant state flux, that is the maintenance of the system, also involves the adaptations of the earlier versions of the software. And the greatest amount of maintenance work is for the user enhancement, improved documentation, recording system component for greater efficiency. And 60% of all maintenance is for the purpose of the maintenance work. Now, what are the various designs, or what are the various ways by which we can maintain that, or we can maintain the designs? So next is a maintainable designs. That is, what are the various design that is used for the maintenance, that is used in the maintenance process. So the keys to reducing the need for the maintenance while making it possible to do the essential task more efficiently are these. That is, more accurately defining the user requirements during the system development, assembling the better system documentation. Better means the good quality system documentation that is required for the system implementation, that is required for the system, we can say the documentation or system implementation or system maintenance, and using more and more effective method for the designing the processing logic and the communicating it to the project team manager. So provides the effective methods, good methods and relevant methods for designing the processing logic and communicating it to the project team members. Then making better use of the existing tools and the technique. That is, what are the various tools that is used for the existing tools and techniques. Then managing the system engineering process efficiently. So what are the various system engineering process that is used efficiently? And as indicated by the preceding comments, design is both a process and a product. That means design is both a process and the product that is carried out with the designing part, and the design practices followed for a software dramatically affect the maintainability of a system. So what are the various good practices that is designed or that is used for the software that affects the maintainability? One is a good design practice makes or produce a product that can be maintained. So it produces a product that can be maintained with the system requirement, with the maintainability of the cost, with the maintainability of the system, by which the system or by which the design or by which the tools should be or the product will be manufactured. And the next one is the software design. These principles should include or should guide the software design. What are the various software design or what are the various principles by which we can improve or by which do the software design? So first is modularity and the partitioning. So dividing the main module into the or main program into the multiple module, that is a modularity. And partitioning. Partitioning means making the partitions or dividing into the multiple parts, that is known as a partition. So each system should consist of hierarchy of the modules, and low-level modules are generally smaller in the scope and size compared to the high-level modules, and serves to partition into the separate functions. So that means dividing the main function into the multiple parts into the multiple modules, and that also divided further into the same separate functions. Next one is a coupling. Modules have a little dependence on other modules in a system. That means one module is dependent on another module. Then cohesion, that module should carry out a single processing function. There is a single processing function that is carried out by the module, that is carried out with the help of the cohesion. Then the span of control. So module should interact with and manage the functions of a limited number of low-level modules. Then size, the number of instructions that is contained in the module should be limited to that module size that is generally small. Then shared use, functions should not be the functions should not be duplicated in a separate module but established in a single module that can be invoked by any other modules whenever there is a requirement. So whenever there is a requirement, that modules will be separated, that modules will be carried out with the established manner within a single module that can be invoked by any other module whenever there is a requirement, whenever there is a need. Next one is, or the first one is a top-down, bottom, or top-down approach or top-down structure of the module. These are the methods, or this method are used throughout the analysis and the design process. So this method is very effective. As the name advises, top-down approach. We are proceeding from the top, that is the root node, and moving further till the process will be broken out into the different or into the separate functions. That is known as a top-down structure of the top-down module. This method are used throughout the analysis and the design process, and the value of using the top-down approach starts at the general level to gain an understanding of the system and gradually moves down to the level of the greater detail. That means that detail will be understandable by the user, that is in the great detail. And in the process of moving from top onwards or top downwards, each component is exploded into the great detail. And one data flow diagram became several at the next lower level. That is, one DFD became next DFD for the next level of for the next lower level. And during the discussion of the input and the menu design, a top-down approach was emphasized, and the main menu contains multiple choices, and making one choice producing another menu. That is a detailed version to the user. So top-down approach or top-down method is also widely used in the systems engineering and the software design. And each function the system will perform is first identified and developed in a greater detail. As I said that the main function is divided into the multiple modules. That modules will be divided into the multiple functions that will be carried out within the single module within the developed programs. For example, when we talk about the accounting system that consists of the multiple modules that are invoked one at a time, as user indicate the particular function they wish to perform. For example, login, that is one of the main functions of one window will be opened, that is a separate module. Forgot password, that is a separate module. And each upper level module in turn leading to using one or several lower level modules until the desired function is performed. So until the function is performed, so that will be used for the lower level modules that is used for the multiple low level module. Next one is a coupling. That is very important question. What is the difference between the coupling and the cohesion? And this is also explained in a graphical format. This we will do later on. So first of all, understand what is the span of control. So that span of control refers to the number of subordinate module that is controlled by a calling module. So whatever the subordinate, whatever the, we can say the sample module that is controlled by the calling module, that is a span of control. And in general, we should seek to have no more than 5 to 7 subordinate modules. So there are not more than 5 to 7 subordinate module that is carried out with the span of the control. On the one hand, excessive span of control, meaning a high level of or high number of subordinate module. Yeah, hi Joseph, how are you? Are you able to hear me, Joseph? Hello. Yes, tell me, Joseph, any queries, anything? So that span of control means a high number of subordinate module that creates a considerable overhead in determining which module to invoke under the certain conditions. So when you will submit your assignment, because I have to make the report for this assignment and send to the external verifier. That's why I'm asking when. What is the deadline? You tell me your deadline. What is the deadline? What is the exact date when you submit the assignment? Yeah, are you able to hear me, Joseph? What I'm trying to say? Hello, 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 hello. So come back to the span of control. That meaning the high number of subordinate modules that creates a considerable overhead in determining which module to invoke at a certain condition. That means, for example, if there are 4 modules, so which module is invoked to for the condition for certain condition, and then establish the calling sequences to pass the data and then receive the result. For example, if the module is not of the high priority or the top priority, so we can request the module, we can stop the module for a while, and on the other hand, it typically results from not adhering to the coupling and the cohesion objective discussed previous example. So if you are able to hear me, then tell me what is the deadline for sending the assignment? No. What will be your deadline? That is past. I know. What will be your deadline to send the assignments? Deadline means when you are capable to do the assignments till the date. Okay, what about other assignments? Okay, not an issue, but next week means next week. I cannot delay after the next week. This is only for you, Joseph, because you are the regular student and you are the regular consultant with the assignments, but this is only for you. Don't share with any other student. Okay, any other doubt, Joseph? Okay, welcome, Joseph. Left with the three modules only. Three modules have been left, and there are 3 months that is left. That is July, August, and September. Three modules, 3 months. That is finished after the September. Any other doubt, Joseph? Yes. Yeah, last module for the project. That is not you have to make the project. No, but only the simple the project, that is the project employability and the development, how to create the project, nothing else. In that module also you have to submit your assignments. Any other doubts? Okay, all right. Next one is a module size. That what is the main module size that will be used for the recruitment for the